Okay, so I want to talk about professionalism in testing, and this is a subject close to my heart, and I know to Isabel's. Let me crack on, and I'll try and explain what I'm about. What I want to do is to kind of explore a few questions, again, Isabel paid some reference to some of the things I'm going to talk about, and I've got a different, not a different perspective, but I've got a perspective of impatience that if we are going to be professionals, we better get a move on. But we need to address some of these questions, like, should we even bother? Is professionalism something that's out of reach for our business for the time being? Is engineering the right profession? So we talk a lot about, when we think of being a professional, most people think, oh yeah, an engineer, like an engineer, not a lawyer or a medic, a doctor, but an engineer. And that seems to fit our kind of cultural perspective. But is engineering the right profession? It could be that it's not the right profession. Are we ready to make it a profession? Is another question that we have to ask. Again, I'll reference Isabel's talk she did in 2007, a long time ago. Okay, and her timeline potentially was a 50-year cycle, to get to be a profession. And if you compare software engineering, if you want to call it that, with, say, civil engineering, the Institute of Civil Engineers was established, I think, in the 1830s. And there are many crafts and engineering disciplines that have been around for approaching 200 years. And software has been around for nothing like that. And if you think about the problems to be solved by civil engineers, the guys who built the pyramids were solving those problems 4,000 or plus years ago. So we are a very young industry still, and it's a very obvious thing to say. But I think it's a reasonable thing to say, well, when are we going to start, if we're going to start to start this journey? So once again, I want to thank Isabel, who I was kind of thinking she might give a talk like this, but then strongly suggested she'd rather talk about her research, which is absolutely great. I'm really pleased. It gives me it gave me an opportunity to think more carefully about things I want to say and talk about. So I want to talk about software testing and engineering, and as a kind of a spoiler alert, I've been thinking and talking about this since 1996. So I imagine there's a few of you who weren't even born then, but could help us. So if you like, what I want to say is that it's always been on the agenda, this concept of professionalism in our industry, but the opportunity to make it happen seemed distant 25 years ago, but we'd better make a start. And we didn't make a kind of start, but it's hiccuped a bit. In 2007, Isabel gave a fantastic talk and wrote a really good paper on what professionalism is about. And I'm going to talk about a little bit of that, I have to say. But we have struggled to make a start. And if we have made a start, we're not making an awful lot of progress. So as I say, my perspective on this is I'm impatient, So I want to see it happen in my lifetime, if you like. I don't want to wait 50 years. Good heavens, no. So I have to say, when I was a lad, 40 years ago, I was an engineer. I did an engineering degree. I was going to be a civil engineer. I did an MSc in concrete structures. I was going to design beams and slabs and columns and so on and so forth, concrete dams, who knows what. At any rate, from my university days, my understanding of what an engineer is would be this definition 2A. The application of science and mathematics by which the properties of matter and the source of energy in nature are made useful to people. That makes a lot of sense to me as an engineer. Okay, that's what engineers do. Now, I know there's another definition just below that, but I'm just going to use my old school kind of view just to make a couple of points. What do engineers do? Well, when I arrived at my first job, I was in a consulting engineer's office. I had a tiny little desk, but my place of work was a stool and a drawing book with drawing instruments, calculator, and so on. And the calculator I arrived with was, I mean, if anyone remembers this, you are you are long in the tooth. I got a proper calculator. Every proper engineer has an HP calculator. That was the rule then, and that's the rule now. Okay, programmable calculator. But essentially, what engineers do is they think about problems, they make models, they produce usually drawings. I did a bit of civil engineering, so that's why I'm using that kind of example. But it's the same for all engineering, but with a different kind of it's a different business domain. We used computers back in the day, and obviously computers are very prominent in the way engineers operate now, needless to say. And I was working on a thing called an AM Jacquard, which is this rather unhappy looking piece of hardware. Whereas I had a colleague who worked in the same office who was working on Cray computers, that's Seymour Cray. So he was working on a supercomputer, as it would have been called in the day, and I was working on a little 128K micro. What the hell? It's all the same. Now later on, I got to work on a digital VAX computer and did proper work in Fortran rather than BASIC, which is a proper engineering computer, if you like. Now, what engineers do is they take the output from what people do in the drawing office and make use of the drawings that used to be hand-drawn, more recently would be generated by computers and CAD/CAM kind of software. But what engineers do is we understand requirements, we look at, we do a site survey, look at the environment, soil conditions, access roads, whatever. We design and create models, which are our drawings, our designs, if you like. We plan projects, we put together bills of materials, all the 100,000 pieces of stuff that need to go to build an office block. We look at people, resources, plant schedules, blah, blah, blah. And we build stuff against those models. Our plans, our drawings, the formula we use are all models of reality, of some aspect of nature, or the materials we use. That's what engineers do. Now, engineers, and I'm talking, with the historical view, but which is still appropriate for modern civil and mechanical engineers. Engineers can't avoid measurement. They can't avoid calibration and accountability. For example, again, my first day, I was given half a dozen calculation pads, pads of graph paper with some headings at the top. And you'll notice the headings include a job number, so I knew which project this was on, a sheet, whatever. Calculated by would be me, and a date. Checked by would be a peer who reviewed everything. Everything I put on these calculation sheets, they would review and check and say it was checked and sign it. Notice also it's graph paper. It's not lined paper, it's not blank paper, it's graph. So you can draw things to scale, and the scale is part of the content of the media itself. Okay, so if you like, we didn't use blank sheets of paper. We used something which enforced a review activity. It enforced an understanding of scale, where there were drawings. It enforced a configuration management regime, because when it came to the next version of a calculation, you put SS with two broad lines across every sheet of paper in the old version, superseded, and we started again with another same job number, but a different sheet number, calculated by, checked by, and so on and so forth. And that was a revision. So we had this notion of accountability, measurement, and calibration. So the very medium we worked on has a grid for sketching models and managing accountability. Now, I was employed on my first day. I was told there was no work for us to do at the moment. So I was told there was a computer in the corner of the room, and the boss said, here are the manuals, go and have a play, tell us what we can do with it. It was a relatively small office, about 15 people. There was a much bigger head office, in Kent, but I was in like a smaller outpost. At any rate, I spent most of my time programming, I have to say. I did a little bit of engineering, but not a huge amount. Now, the thing about engineering software is there's a physical reality that you're working with. So if you're working on the Severn Bridge, a suspension bridge built in the 60s, the calculations of every element in that bridge, every cable, every decking slab, the pillars, the suspension cables, every element has to obey the laws of physics. And when you calculate all the forces in 3 directions, and including the rotational forces in these elements, they all have to add up to 0. Otherwise, that element would go spinning off into space. So there's a physical constraint that you can count on to regulate what you're doing. So, if you like, engineering software is a little bit easier to test. Now, I have to say, when I was writing software on behalf of engineers, they tended not to be very interested in testing it themselves. They trusted what I did. Now, maybe they just thought I was very good at what I did. I don't think so. But because it's engineering software, if it looks right, it probably is right. And that kind of mentality went through to software, as well as the physical elements that would be on site, in an embankment dam or a bridge or a road or whatever. Now, the question I've got is software engineering? Well, I have a problem with that because software does not obey the laws of physics. There are no reliable tested laws at all. There are no mathematical laws that we can trust to the degree that we can predict the behavior of software before we write it. We just can't do that. And that has caused me a lot of grief over the years, in that I'm not sure it is engineering. Now, having said that, the high integrity industry, airborne software, fly-by-wire kind of stuff, signaling, engine management systems, all this kind of stuff needs to work, needs to be very well tested, and it tends to be designed using engineering approaches. That is, rather bureaucratic, very detailed modeling, very process-heavy approaches with reviews and inspections, a lot of testing, automation where appropriate, blah, 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 blah. Okay, that's software engineering, has its place. Universities who like to turn crafts into science have aligned themselves mostly with that area of the industry, the high integrity arena, and they call it computer science, and that's reasonable to do. The thing is, I don't think these reflect what happens in the real world, because software engineering, I don't think, is the ultimate goal. Software engineering is a part of systems development and the approaches to system development. I don't think engineering is at the core of what we do. However, that culture is what we want to do. We do want a more sophisticated approach to what we do, and if it means calling ourselves engineers, then so be it. I think that's the right thing to do. But if you pick up a software engineering textbook, most organizations cannot use the contents of that book to make progress, because most of us work on systems that require constant change. And of course, there are processes to deal with change management and configuration control and regression testing, whatever. But if things constantly change, software engineering approaches become very cumbersome indeed. So what happens is we don't apply them with discipline, or we don't apply them at all because we get into trouble. And in one way, waterfall has been the victim of being promoted as a solution to all our problems, and it just is not. And that's why Agile came along as a response to the problems that we had with waterfall. So, although software engineering exists, it's not the ultimate process we should aim for, is my thesis. Okay, so next thing to talk about is a body of knowledge. What should testers know? What should people who test know? Now, there's a thing called SFIA, Skills Framework for the Digital Age. It's well-intentioned, but I don't like it. And I'm not going to spend a lot of time criticizing stuff because I don't think that helps anybody. But if you like, the scope of testing is squeezed in to one of 8 skills, development and implementation, and system development is a sub-skill, and testing is a sub-skill of systems development. Acceptance testing has its own kind of entry, and that fits under change and transformation. So be it. But SFIA makes very little mention of interpersonal skills that have value to testers. There are some interpersonal skills, but they're more to do with HR and learning and development. SFIA references 54 what was I going to say? 54 bodies of knowledge. Sorry, I forgot what box was going to say. What box was. 54 bodies of knowledge. For example, the project management body of knowledge is very well established, been around for donkey's years, and is very trusted. I mean, it's you could say it covers every base conceivable, but it's very well established. SFIA is relatively lightweight in comparison with the bodies of knowledge that many areas of software already have. So SFIA is not necessarily that helpful. The body of knowledge that that SFIA references for testing is the ISTQB syllabuses, which is, I don't think that's good at all. Now here's the whole layout, and it looks very kind of well organized and structured and color coded even, and yeah, wonderful, wonderful. Testing sits there in the middle. Great. So testing could be between 20 and 70% of a project, but literally is like one skill in 100. It's not given the emphasis that I'm sure it requires, because testing is pervasive. Everybody who does almost every other activity and has every other skill on this diagram does some testing. Testing is kind of it's an activity, not a role. It's not just testers who do testing. So SFIA, I'm dwelling on it because I think it's a mentality that makes people think it's a good thing to do, because it shows some structure, you know. A tester is a tester is a tester, and the skills that SFIA present, it's a bit like sheep dip, you know. We are trying to say these are the skills you need as a tester, but every individual who's ever done testing knows it's more complicated than that. One of the problems we have is, again, with SFIA, it doesn't mention coaching, it doesn't mention technical and business skills as part of a tester's makeup. And testers, it stops before you hit the strategic aspect. But testers have to do some strategic thinking sometimes, because testing might be the single biggest activity on a project. It's as simple as that. So I have a problem with it. Now, if we are going to create a testing body of knowledge, I don't think ISTQB gives us what we need. It's a set of syllabuses, and they are fit for purpose for being syllabuses. They're not fit for purpose for being a body of knowledge. One of the challenges we have because of this is ISTQB don't manage their stakeholders very well. Let me say that. So ISTQB press on and create more and more syllabuses that are widely distributed, but also widely disputed in the testing community. So when they request comments, 15 years ago, or whenever they put out the first or second foundation syllabus, they got many thousands of comments, and because of the volume, they had to ignore them. They couldn't make progress, and that is a problem for us. You know, it doesn't represent the set of skills that the testing community believe is important. SFIA, ISTQB, out of scope, things like critical thinking, communications, requirements models and modeling, production monitoring, working in continuous delivery. I mean, most of these are just not mentioned. They're not given any time at all. Maybe that's because they're out of scope, but that does not help the testing community. It seems definitely that SFIA levels 1 to 6 follow a strict waterfall approach. There's no mention of agile, continuous delivery, modern approaches. And also, it seems like an afterthought to even include ISTQB as the body of knowledge for SFIA. There's no justification for doing it. I really don't like that. So how do we build a credible testing body of knowledge? We have to recognize that the certification schemes focus on what I call logistics. Now, logistics are really important. So incident management is really important in most projects. It's critical. You know, we need to do that right. But the way you do it is a choice you make. The problem with certification schemes is they give you one explanation of how it could be done, but there are many ways of skinning that cat. You know, there's the problem we have with certification schemes is it tells you a selection, a partial selection of ways of doing things, but it doesn't give you the whole story. It also tells you nothing about how you make the choices of which way is best in your context. And this is the basis of the argument from the context-driven people, you know, which is there's more than one way of doing things, and different ways have different values in different contexts. We have to take account of that. And that's kind of obvious, but it's still, after 25 years, not being done, not being implemented as a set of skills to adapt testing, to make choices, to make design decisions. What we miss are the skills to solve complex problems, and no one who works in testing is in the business of having to solve simple problems. That's where we're at. Glossary of terms. Okay, so one of my maybe heroes, I guess, Socrates. I cannot teach anybody anything, I can only make them think. I think that's reasonable. Socrates was told by somebody that the Delphic Oracle said that Socrates was the wisest man in Athens. And he thought, because he was a pedantic so-and-so and possibly autistic, I don't know, he doubted it. So he said, well, I'm going to find someone wiser than myself. And if I do that, I will disprove the theory of the Oracle. And that would be a blasphemy. And so, anyway, he asked questions, and what he discovered immediately was people do not use language consistently. People didn't understand what he was asking, and the answers they used, even when they used common words, they used them in ways that obviously meant different things to different people. A consistent set of definitions is required. In 1993 to 1997, I was part of a working party to develop a standard for component testing. And after some months, there was like a year's work before I got involved, and then we restarted. And several months later, we still had quite heated disputes. I remember them very well. And I made the kind of obvious observation that we didn't have a glossary of terms. Maybe we were just talking at cross purposes a lot of the time. So I said, right, okay, we've got about 70 pages of text. I'll write some code to scan the text to pick out every 1 to 4 word term. And I printed them out in alphabetical order and scanned them by eye. I think there were about 10,000 phrases. And it sounds like a terrible task. It actually took an afternoon. It was really quite easy. I picked out about 300 terms that I thought were meaningful, required definition. And by doing that, that formed the basis of a British standard, BS 7925-1, software testing -vocabulary, and the standard was -2. And that was in 1998 when it was published, although the work was done a couple of years earlier. We still have a problem with terminology. It's a fact. We still have that problem. Now, I want to suggest that what tends to happen is people don't like reusing other people's definitions. It's like this not invented here kind of syndrome. And that's a natural thing to do, but it's caused us all sorts of problems over the years. Because what tends to happen is people choose their own definitions or make them up themselves. They're not referenced anywhere else. They're only of interest to that one person or that one team. They're often too parochial, that is, they're limited to a single business or a single team even, or they're too general, they're so vague as to be useless. It's really hard to come up with very good definitions that are coherent and meaningful. Now, there's lots of standards out there. BS 7925-1 is one, but it's superseded, needless to say, since it's so old. And many books have glossaries of terms. The first one I could find on my bookshelf was Software Testing Techniques by Boris Beiser, 1990, which is the first book I ever read on testing, I should say. My own book with good friend Neil Thompson, we put a glossary in because we knew this was a sensible thing to do. And we referenced standards, we referenced other sources where we could, but we had to invent terms ourselves because it was about testing the internet. And this was into the year 2000, 2001 when we were writing it. So these terms didn't exist, so we had to create some definitions. It seemed sensible to put a glossary of terms in. And some other books, Lisa and Janet's book, Agile Testing, of course. But most books don't have glossaries at all, and most authors would defend it by saying, read the word you don't understand in its context and you'll figure it out. And that seems to be the attitude in many places. Now, the other angle, this angle and this attitude is not new, but it's very understandable. And Kankana, James Spark in their BBST testing course, I don't know when this was written exactly, but you can see the date at the bottom is 2000 to 2010, at least 22 years ago. James said, we'd rather embrace the genuine diversity of our field than try to use standards committees to hide it or legislate it away. So they were very anti-standardization because we're not in a position to standardize things perfectly, to get everybody to agree. That's kind of understood, I think, by most people. But the other angle is, when you are in a conversation or you're reading a document and there's something you don't understand, you should ask the person who wrote it or ask the person who spoke it. That's just the way you have to be, which is, okay, it's a way of getting around these problems. However, doesn't it waste so much time? And a lot of the time, junior people do not like to ask senior people, what do you mean by test case? What do you mean by integration? What do you mean? And so on. It's a barrier to progress. And I have to say, it reminded me of Humpty Dumpty through the looking glass, bless him, on the wall. He said, when I use a word, it means just what I choose it to mean, neither more nor less. And Alice says, well, surely it's hard to make words mean so many different things. And what Humpty Dumpty said, well, who is to be the master? Are humans to master language, or is a language to master us? The problem we have is when we grow up learning language, we adopt definitions in our own heads that may or may not be correct, but also are very hard to shift as time goes on. The same goes within our professional environment. We find it very hard to undo the definitions that are hardwired into our heads. So we need some pragmatism. I'm not going to talk about this. I'll talk about it in the other talk, I think, because I'm running a little bit tight on time and I'm already going too fast. So I want to say this. The state of the profession is test engineering, perhaps, is a thing to do, is a good professional goal to define a test engineering body of knowledge. I don't think software engineering is the only way. We have no agreed testing body of knowledge, but we don't even have a set of testing definitions that are coherent. So in the next talk, I'm going to talk a bit more about, well, what do we do next and what's the opportunity that we may have? And I want to know whether you think we may have that opportunity and to step forward and say, okay, we have to wait another 25 years, Paul, before you get involved again, or we could make a start. And that's what I want to talk about in the next session.